Oh, there we go. I forgot to start the recording. Just means I'll cover that a little bit in a sec. Just suddenly realised. Yeah. So last time we were talking about batteries. These are the batteries that we're using, the little micro droids, the little 6 volts or 4.8 volts.
Doing tonics. I'm trying to be good here, holding me.
You had one beer down there, everybody.
No, I've only had one.
As we get into the bigger builds, that's where we then start to use some bigger batteries. So typically in the R2 world, we'll use sealed lead batteries, which are the ones on the top left, or we can use things like lipos, which are these kind of devices. So when I go through the track droid, what I'll do is I'll talk you through using a lipo, but effectively you can use either of these power sources. All these things we've got on the screen at the moment, they're some of the main components that you see in these builds. I think the biggest challenge is when you see a massive wiring diagram, or you see people posting photographs of their build, and there's displays on there, there's glowing switches, there's LEDs. It looks incredibly complex. So what I'd recommend is starting really at the basics. Just grab a battery and start to build a system up from absolute scratch. And this is the one that, as I said, that we've got in the track droid, which is literally a power supply, remote controller, and speed controller, and that's all that's in there really. So it's a really basics. So that's your batteries. We covered these in a little bit of detail last time. With lipos, really do check out the safety, all of the safety recommendations on lipos, because they can be quite dangerous. What we didn't cover last time was a little bit around voltage converters. So when you're running a larger system like the droids that we're using, ideally what you want is one power supply, whether that's a big 12 volt or 24 volt battery, but you want it to power the whole of the droid. Very similar to what you get in a car. So in a car, you've got one big battery, you've got an alternator that charges it, and then that can power some of the high voltage, the 12 volt lines. It can also power some of the logic and the lower voltage ones. So what we do is we take the 12 volts and we start to step it down or convert it to 5 volts. And again, there's lots of options for this, but all you're really doing is running cables from your battery to your power converter, and then the output of that you're running to your 5 volts. So you can wire these however you want to. I've got a couple of examples here. One's this little buck converter at the top. That'll take 12 or 24 volts input, and it'll output 5 volts, and it'll give you 10 amps. And again, we touched on it a little bit last time. The very basics, you know, voltage is your voltage, but ampage is your actual power. That's how big a motor you can drive or how many servos you can drive. So the higher the ampage, the more devices you can kind of start to build with that. Does that make sense? Yay! I'll take that as a positive. The ones that I tend to use, I use these little UVEX. Which I think I've got one somewhere here. There's one there. So I don't know if you can see the video, but they're really small devices, and they work incredibly well with the lipos because you've got a very large voltage that you could range that you can put into this. So this little one that I've got there, which is tiny, will take between 7 volts to 25 volts, and it'll output 5 volt. So I can connect this pretty much to any of the big batteries that I'll be using to run things like R2. And what it gives me then is a steady 5 volt power supply that I can then run Arduinos off, and I can run servos off. So typically within the big R2s, we've got some things that run on high voltage, like your motors. Often your amplifier might be running off 12 volts. And then you've got a load of stuff that will run off logic voltage of 5 volts. So the way you kind of get your voltage into the system is by using a voltage converter. And again, lots and lots of options on how you actually connect those and ones that you can buy. A couple of other things on there. Now, I've not got these at the moment on mics. This is an absolute bare bones one, but there's a fuse box. what's prudent probably is to at least fuse your 5-volt line and your 24-volt line, so, or your 12-volt line, your high voltage, your low voltage, with a suitable fuse based on what you're actually running on it. And then what happens if you get any shorts or you get anything that's going to sort of start to melt cables, your fuses will blow. As I said, they're not essential for it to work, but they're a really good and highly recommended kind of safety thing that you would have. And then there's a couple of other things to the left-hand side which you'll find in many builds. You'll find obviously switches. Many builders will have multiple switches, so they'll have separate switches directly for the motors so they can safely isolate both of the leg drives so that you can't roll off or move anywhere, along with the main switch then that switches the power. But again, you can make this system as complex or as simple as you want to. So, you know, from very basics, you can have a battery, a speed controller and your basic RC setup, and at the other end you can have all sorts of switches and displays and monitors that sit in there. So again, these voltage displays you'll often see on some builds. It'll tell you the voltage check on each of the different systems that the droid will actually be using. So just looking at that, I just want to touch on speed controllers next. The one that we use well, the ones that I always use on the big R2s and the track droids and whatever, is Sabertooth. Now, I would say they're bloody expensive, to be honest, compared to some of the things that you can buy. You know, you're probably talking around about 110, 120 pound, or was that 130, 150 $150 for a Sabertooth 32 amp driver. And you know, whereas if you were to buy, you can buy cheap 20 amp speed controllers for about £5 or £6. So again, there are options. The advantage of the Sabertooth is they are incredibly reliable. They've got great support from the manufacturer, and they're kind of the standard really that people tend to put in these. And to be honest, if you're running something the size of R2 around, you want something that you can rely on that's going to control it. But there are cheaper options, and as I said, you can run these on cheaper speed controllers. What you also find with some of the cheaper speed controllers is they'll make a little bit of whistling noise when you're going at slower speed, which can annoy people. So the Sabertooth ones are absolutely outstanding, really. But again, you certainly do pay for them. So and I think people are probably familiar with these on the pad ones, you know, and the more complex ones. But to run these on a very, very basic remote control setup is really, really simple. So on one side, these really big connectors you've got are where you've got your high voltage. So where your main power goes in, which is typically 12 volt or 24 volt. You've got your two motors, which is your left and right drive motor, and that's it on the high voltage side. And on the other side, then you've got some connectors which allow you to really just take the signal from the RC. So that S1 and S2 just at the bottom, if you can see that, is where your main signals come in. And then the other advantage that the Sabertooth does is it gives you a 5-volt supply. So it takes whatever your battery power is, and it'll give you a nice solid regulated 5-volt supply that will power your RC receiver and any other devices that you're kind of running at 5 volts. And then other than that, really, you've got a few dip switches. So the kind of quick reference guide that you get with the Sabertooth is fantastic. It will step you through each of the different setups, but this is a setup for your basic radio control. So the one that I've got sat in the track droid is pretty much like that. So the first two configure what mode it's in, off on switch 1 and on switch 2, and then you've got 4 different things that you can switch around. Now, the switch 3 gives you a choice between battery and power supply, and it's not actually battery and power supply. What battery means, it means a LiPo. So it means the specific type of battery. And what happens if the voltage drops below a certain voltage, the Sabertooth will start to switch off. Now, one of the gotchas that I found quite early on is I'd switched it to battery when I was using a lead acid battery, which was kicking out 12 volts when it was expected about 14 volts from a LiPo. So it run really sluggish and really slowly. So unless you're running a LiPo, keep that to power supply. The next switch is either independent or mixed, and what that is in our language, I guess, is tank control, or what you would see as a traditional servo type thing, where it would drive each of the channels independently. So if I just, I think I've got, so effectively tank control is a bit like this. So if you put the stick forward, it drives both of the left and right motors forward. If you go left, it spins one side forward and one side back. And what that means is the Sabertooth actually can do that mixing for you. So that's the difference between independent and mixed. The next one is exponential or linear. What that means is linear means the more stick that you apply, the faster it will go. Exponential puts a bit of a curve on it, so it slows it down at the lower speed, so you've got a little bit more control over it. And then the bottom one, you just got flipped transmitter. So, and again, these are really well documented. But if you want to run R2 in absolute bare bones basic mode, you put that configuration that we've got on there, and then what I'll do is I'll just show you the setup. This is currently what I've got connected in mine. I'll just talk through this, and then what I will do is jump into the actual track droid, and then you can have a look at how it's all connected. So really incredibly simple drive, and if you've just built a couple of drives, or a couple of foot drives, you started to put it together and you want to test it before you built your pad one, you want to just check the motors and make sure everything's running. You've got your Sabertooth to hand with a basic RC receiver and controller. You can fire it all up and you can just have a little bit of a spin round. The other thing to just be careful of is the speed at which, when you first connect it, that you may find that the thing shoots off at a ridiculously fast rate. So you may need to trim it back a little bit. We've had a few of those, but as a basic setup, this works really well. So what you've got is a battery, as I said, 12-volt battery or a LiPo battery. I tend to use these 14.4 volt LiPo batteries just to test. This is 5,500 milliamp hour, so I get a reasonable couple of hours running on R2 out of these batteries, and they're tiny, and I can just throw them in and take them out and charge them. On Chopper, I've got one of the bigger lead acid batteries, which last a little bit longer. But again, for testing, they're great. And literally, all you've got to do is make a cable so that it connects your battery into your main power. And then your two motors are connected to either side, motor 1 and motor 2. The only gotchas on these really is making sure that you've got the polarity right, so that when you put your stick forward, it moves forward, and you pull the stick back, it moves back. The only way the way I tend to work on that is there's no science with it. It's just trial and error. I just wire it up, connect it up, screw it in, push it forward. If it doesn't move forward, I'll try switching these round till I get it to actually work. And that's your high power side. So that's your 12 volts all done. On the other side of the Sabertooth, that's where your 5 volts logic kicks in. And as I said, what you've got within the Sabertooth is it can output 5 volts and ground. And so what you do is you connect your 5 volts to your receiver, you connect your ground to your receiver, and then you just need to take your 2 signal cables from channel 1 and channel 2 and put them into S1 and S2 on the controller. And that's pretty much it. It's an incredibly simple configuration and setup if you just want to set a basic RC setup for R2 or for any of the larger droids. Again, the only kind of gotchas on these is making sure that you've got all of the polarities right. So you know, if it's going backward when you want it to go forward, you can swap the cables round. You can swap left to right and right to left. You can also swap your signal 1 and signal 2 cables round from your controller, and each time you flip it over, it'll do the opposite. So it's a little bit of trial and error, but it literally, you know, for me, it just takes me a few minutes when I first wire these together. The other thing that you may want to add into the very, very basic one is something to drive the dome. And again, it's another speed controller. So I've got one there, which is the Siren 10, which these little things. Again, dimension engineering speed controller similar to Sabertooth. They are expensive, exactly the same as the Sabertooth, but you can run these on cheaper speed controllers if you want to. And literally, to add the Siren 10 is exactly the same as what you've done there. You'd run a main power into your batteries. There's only one channel to power your dome, which goes to motor 1 and 2, and then you run your RC signal from channel 3 or channel 4, depending which one you want to on the controller, into your Siren, and that will let you kind of your dome spin. Right, I'll stop there for a second. Any questions at this point? Anything that isn't clear, or thoughts, comments, observations?
Hi, Michael. Steve here.
Hi, Steve. How you doing?
Hello, guys. Yeah, hi.
Hi,
Yeah,
Steve.
I'm good. Hello, everyone. Just as like an observation, and just forgive me, I was a little late getting into this, but just for the benefit of everyone else listening, one of the other major benefits about using a Sabertooth 32 and a Siren 10 is that you can switch between PWM and microprocessor control simply by changing the dip switches. So if you're, I've helped a number of people out with this. If you're running something like the Padawan system, which uses the traditional Xbox 360 kind of controller and a microprocessor like an Arduino to drive them, that's all great. But if you need to do an event where you have to have RC, so in the UK we call this the difference between tier 1 and tier 2, you can very, very simply switch this over, literally change a couple of dip switches, stick in your RC controller instead, and you're good to go. The rest of it, the high voltage side, as Michael was just explaining, you may potentially have to tweak because of the, if you've got a difference with the way that your transmitter is set up to the microprocessor. But no, they are over-engineered and very expensive for what they are, but you can literally just change its, its functionality from being a radio control speed controller to a microprocessor-driven speed controller simply by changing a dip switch.
Thanks, Steve. It's really important point actually, that because if you're building these things, it does give you those options to switch over. But the other thing is also it gives you the options to diagnose where you've got some challenges. I know there was the guy's dirt was really struggling with one channel that was running too slow, and the first thing I asked him is, has he got an RC set up that he could switch it over to RC, because then it rules out all the logic and the code and the Arduino and anything that could be going on there, and just flick it over to RC. And I think there is some setup, Steve, where you can actually where you can switch them over without too much difficulty. So they've kind of engineered it with relatively simple switchover. Is that right?
Yeah, there's a number of different ways of doing it. You could literally just have the plugs that go into your RC receiver, traditional JST, 3-pin servo kind of lead that would go into that. You can just make up a lead that comes out of your Arduino and does the same. So then it's literally a case of, I think, probably one dip switch, which I think is number 2 off the top of my head.
Yeah, and then you're straight in.
Yep. Certainly when I build Padawan systems, I put dip switches 1 and 2 down on both the Sabertooth 32 and the Siren 10, and that's it, and it runs absolutely perfect.
Yeah, the RC setup is incredibly simple. I know people sometimes just have some problems setting up the microcontroller one with the serials and the baud rates and lots of some of the more complex things. But to basically test your system, this works really, really well. Cool. Any? Yep.
I do have a question. So I'm looking at the Sabertooth here, and you have a picture of a 5-volt battery. Is that for testing, or I mean, I'm showing that it's up to 30-volt max. If we're using a 12-volt system, couldn't we just plug a 12-volt straight into that, or?
Oops. Just bear with me. Sorry.
That's not a 5-volt battery. That's 5 amp hours. That's its rating. That's a 12-volt battery rated at 5 amp hours.
Okay, I just seen the 5. Yeah, all right.
Yeah, sorry. Yeah, that's it's 5 amp hours. I think it depends on the number of cells, but I think that'll be a 14.4 volt. So
Okay.
it was a picture off the internet. This one that I've got here is it's 14.8 volts, which is 4 cells, and it's 55 milliamp hours. So the voltage is the voltage that kicks it out, but the milliamp hours is how long it'll run before it needs recharging.
Okay, I just guess overlooked that.
No, it's probably my quickly stealing pictures from Google also that's confusing matters. So.
Now that I look at it, it says high voltage 12 volts. So I just, yeah, you're good. Thank you.
Cool.
I got a question for you, Michael.
Yeah, go for it.
Hey, so I know in your illustration here you show the 12 volts. My 2 motors for the drives are 24 volt. Will it run off the 12 volt just fine?
Your 2 motors for the driver, what, sorry? 24?
He says yes.
Yeah, it will. But they'll, if you're running a very heavy droid, fully aluminium, etc., you've got 24 volt motors, you want to run it at 24 volts because that's where you'll get the maximum push. But for lighter ones, for these, then you're okay.
Yeah, it's the R2 from you, so.
Yeah, printed ones and will be fine with 24 volt motors running at 12 volts.
Okay.
I've got 12 volt motors on mine, and the torque on them is absolutely crazy.
I was wondering if I had to have a 24 volt system since they're 24 volt motors, and then, I've seen some people post that they can do just well. They're fine on 12 volt.
Yeah, my wooden aluminium droid is 24 volt, 150 watt motors, but I run my system at 12 volts natively. Can feel perhaps a touch sluggish in terms of torque because my droid isn't a 3D printed one. It's wooden aluminium and it's quite heavy. But if I select, the top speed on the Padawan system, then yeah, I'll get wheel spin.
What would be my estimate runtime with that one battery for those 2 motors?
For which battery? For the
one that pictured.
I've had about 3 hours, 2.5, 3 hours out of the smaller batteries. Most people tend to do the lead acid batteries where they'll get a full 5, 6, 7, 8 hours running on them. So you do get a good couple of hours, and you can actually run these in. I was getting this confused. It's series or parallel, Steve?
So it depends what you want to do. Series will double your runtime. Parallel will double your runtime. Series will double your speed.
Okay, but the one battery can handle it for 3 hours.
Yeah, around that. Yeah.
It's a difficult one to put an exact number on because it depends on if you say 3 hours. Well, if it's sat for 2 hours just at a con making sounds and spinning its head around, it'll last far longer. But if you're driving it all the time, it'll last a bit shorter. So yeah.
There's little devices, Sean, that you can get that stick on the kind of, you can see these little white connectors on the end of these.
Yep.
And their voltage, they monitor the voltage.
The balancers.
Yeah. So I'd always run those on with an alarm, which I tend to do. The challenge with lipos is if you run them flat, it damages the battery, so you can't use it again. So you have to monitor them a little bit more carefully.
Yeah, I know they're supposed to get down to a certain percentage, and you're supposed to stop.
Yeah. So I mean, these things are $2, $3, $4 that you can get from eBay or whatever, and
Yeah,
you just
I got
plug
them
them on and
Hobby King sells them.
yeah. So it's
Thank
just,
Hey, Michael, can I touch on the Sabertooth 32 for a second?
yeah, go for it.
I did get in late, but I did hear you talk about the voltage cutoff regarding the battery. But what I didn't know is whether or not you mentioned that the 32 lets you select different types of batteries. So you can go lithium ion, nickel metal hydride, sealed lead acid, even lithium. I'm sorry, the metal phosphate ones. Lithium iron phosphate. Yeah.
Okay.
It lets you select everything for the voltages, and it's got the USB port built onto it, and it's the same price as the 2x25. So 32 should be the de facto standard. Don't even look at the 25. There's no point in spending the same amount of money for fewer features and less power.
Yeah.
So, just want to put that out there. Thanks.
No, it always confuses me a little bit as to why the prices for the 25 is the same as the 32, because it can do everything that the 25 can do, really, and more.
Yeah, I'm looking on Amazon, and that's where I'm getting that pricing. I think it's still the same on their website the last time I checked. I'm guessing it's just because it's a more popular model, and maybe their prices come down for bigger mass production or something.
So where you select the batteries, Mark, is that in the software then?
Yeah, I think I can't remember the name of the software. I think it's called Describe or DES.
Yeah, it's Describe.
Describe, yeah.
And that's also, if you don't want to do it in your sketch, you can also do your acceleration curves in there too. It's extremely well featured. But if you use the 25 amp version, you can still do it, but you need a USB to serial adapter and then stick the jumper wires in the signal pins on the 25. It's kind of a pain. Again, there's just no need to get a 25.
Well, on that note, Mark, I have the 32 right here. These little dip switches here, you don't mess with those for that selection. You go through the software.
No, you still do the for the mixing, and the power supply. Those are still absolutely critical.
Okay.
But there's more features to be configured in the software too.
Okay.
Yeah, the software.
Christmas has come early in my household.
How many have you got there, Steve?
A pair of 32s and a pair of Siren 10s.
Right. Well, there was a shortage, wasn't there, recently about them? So, yeah. So that's the basic setups, the dip switches. But as Mark said, there's a hell of a lot in the software where you can choose how fast it ramps up, how slow it slows down. You can run diagnostics. You can also configure all sorts of things on there. So again, they are really incredibly well featured. So that's a really basic setup. So I'll just flick through. I'll throw you inside the track droid now. Just stop that share a second. Spotlight that video. There we go. So this is. So it's very boring inside here actually. When I feel that you need to have a lot more than that. But literally, all I'm really running on here is the Sabertooth. You've got the battery cable in the centre, and then the two drive motors with just a connector on the end for the battery, and then the other side, which is the signal side, I'm taking 5 volts and the ground off this side, and then I'm running the signals in. And I've literally just got a little Fly Sky receiver that's running that. And straight out of the box, to be honest, not configured anything through the software other than the dip switches. So if I just plug that in. Go. We'll put some power in there. So we've got the little green light, so we've got power, and a little red light to say we've got power on the RC receiver, and that's pretty much it. There's nothing particularly spectacular about that. So if I get the receiver, turn this on.
And of course, Michael, you'd always advocate for turning the transmitter on before plugging in the receiver, wouldn't you?
Yeah, I was just about to say that myself.
Sorry, mate.
Of course I would, Steve. Yes, yes. I would, definitely. There's another feature on these. I don't know if you've seen these, but there's one that it has a test of all the channels. And what it actually does is, it's in the configuration, but what it does, it takes each of the PWM signals to the extreme. It's like a little self-test that sits inside here. Never put that on when you've got a droid attached to the end of it. I did it with Chopper, and he just shot off all over the workshop, bouncing off things. It was an absolute disaster. Look, it didn't damage him or the S5 that he crashed into, but it was horrendous. So, yeah, so there we go. So, yeah, that's literally just running on that very basic system. Now, what I have done with this is turned the I'll just go into the setup, see if we can see this. Turn the configuration right down. See how we can show this. Is that the right way around for you guys? 'Cause it's mirrored on mine.
Yeah, that's fine, Mike.
Okay, cool. So on the setup here, oops, I was getting mixed up with these. And the setups here. If I go into the endpoints, I don't know if you can see there. Well, I'm running all of that at 50% because, as Steve was saying before, they're very talky, very powerful those. So running 100%, it had it just shot off at a different a rate that I couldn't really sort of control. There's a couple of other things you can do in there. You've got something called reverse. So if you go into there, rather than reversing the cables on the receiver to get it to go in the right direction, you can reverse the channels there. So you can, it's effectively, it's like a servo reverse. So rather than going far left, it will go far right. So it depends how lazy you are. Sometimes I just think, I'll just do it in the RC rather than get the cable correct that's in there. So if you just press the button, you can just reverse them back and forth. I think the other thing, if I can just get down to the other one that I've also done on this is I put in a slight curve on channel 1, and again this was because it was really keen. So what this lets you do is you can start to, I don't know if you can see that curve changing, but what you can do is rather than do it through the Sabertooth, which you can do with the software on Sabertooth, you can push it along. So what it'll do is it'll start off slower and ramp up at the higher speed, so you've got a little bit more control at lower speeds. So, and I'm not going to go through all of the RC stuff, but there's lots and lots of different configurations that you've got in here. Normally, and I think we talked about this on the little micro droids last time, is normally I would also use a mix, which again I see on there. So I'd have two mixes, which is tank drive. I don't need to do tank drive mixing on this because that's being done in the actual Sabertooth controller, if that makes sense. So that's where we would do tank drive if we were doing it on a more of a sort of a basic function. Let's see if I find that horrible one. Is that horrible one? I think it's. I'm not going to go through it because it is horrendous when it kicks in. It just tests all the different ends of the spectrum.
Hey Michael, do you have your have you messed with your, because I did a lot of RC helicopter flying and stuff like that. So do you adjust your travels, how far it travels on the servo and all that stuff?
You mean the upper and low limits, or
like the travel? I think it's called just travel adjustment. so that the servo only swings so far to the left, but more to the right, that kind of thing? Have you ever had to do that? Okay.
Yeah, you can do that. Again, with this setup, I don't really need to. But what I can use, I use that to tone the speed down. So I can, rather than it running at 100% on either side, I run it at 50% either side. I could run it 100% in reverse and 50 forward, which means it go a lot faster backward than it would do forward. So you can use that to tweak the speed with speed controllers. So it's exactly the same sort of thing, really.
Like what Steve said, endpoints, your endpoints.
That's it, your endpoints. Yeah. That's where I'd use the endpoints just to turn the power down a little bit. Otherwise, they go too quickly. With the Padawan, you've got 3 settings that let you go slow, medium, and very fast. With RC, you obviously haven't, but you can adjust the endpoints. But to be honest, once you've got something that sort of works, then you tend to leave it. And
Can you adjust endpoints on the servo controller?
The what? Sorry.
Can you adjust for your endpoints on a servo controller? Because I've been using the Pololo Maestro controllers on my Johnny 5, and you can adjust endpoints on that.
Yes, you can within a certain limit. So the endpoints, I'll just so you can go into endpoint settings on here, and at the moment I've got these to 50%. If I go down to one that's not being used, let's go to channel 3. There we go. So what I can do is I can move channel 3 up to 120%.
Yeah. All I said is I've got a controller, but my controller can't do that. So I wonder if I can do it anywhere else on the system. Because I know on Pololo Maestro servers, you can, Maestro controller servos, you can do it. But the problem is it was a little bit awkward in controlling those controllers via an Arduino.
Yes. I don't think you can do it at the servo receiver end. You can only do it at the servo transmitter end that I'm aware of, certainly in the FlySky. And again, what you're talking about...
You've had a fruit servo controller, haven't you? Is there anything on that you can limit the servo movement?
You've had say that again, sorry?
On your Adafruit servo controllers.
Yes.
Can you adjust the end stops on that?
Yes.
Yes, that's basically what I was asking. Yes, okay.
Okay, so on the what you've typically got in a servo is the sort of standard ranges is from 1 millisecond to 2 millisecond with 1500 in the middle, and that doesn't necessarily give you the full motion of the servo. It gives you quite a limited motion of the servo. On the RC controller, I can push it up to 120%, but I still don't get to the end stops. With the Arduino, I can chuck any number that I want to the servo, and with the Arduino, I can push it up to its end stops and sometimes beyond, which may damage the servo. With the Adafruit servo controller, I can still send that signal to the Adafruit servo controller and still push it up to where it beyond its end stops are. Similar to what you can do on the Maestro, just the Maestro gives you a bit of a nicer interface in the way that you move that, if that makes sense.
Yeah. Does anybody use the Maestro for connecting? Because I was using those for my Johnny 5, but then I contacted Pololo and they said, I can't control that Maestro using an Arduino. What I basically asked them is if I had preset sequences for the servo movements, and then I wanted to select a sequence using the Arduino.
Pololo said you couldn't do that.
Yeah.
That's kind of what they're designed to do.
That's what they're designed
that's what I thought.
They absolutely can do. We did a little one of these sessions on the Maestro, which is exactly what we did. I put about 3 or 4 different movements or animations through, and then you just send that particular animation number that you want from the Arduino, and it runs it.
Oh, okay, because that's exactly what I wanted. That's exactly what I asked Pololo, and they said no, it can't be done. They can't interface with an Arduino. They said.
That's mind blowing beyond mind blowing. I don't know. I mean,
Yeah, the person must have replied, must have just been sacked or something. Then I don't know.
it's weird. Yeah, Chopper. I mean, all of Chopper's animations with the arms coming out and the lights coming up, they're all running off Maestros. And I like
Okay.
to send the script. If you get the Arduino library for the Maestro, it's actually got a script example in there, so it steps you through how to do it.
Okay, cool. Shall we look
As I
into
said,
that?
there's one of these sessions I recorded as well if you wanted to sit through that.
As I was just, I'll be going that way because I've got about 5 or 6 Maestros, so that's what I'll be doing.
But like Steve said, I mean that's pretty much what you're dying to do. So God knows why you sort of got that answer in.
Yeah, odd. Okay,
Very
thank
weird.
you for that.
No problem. Any other questions before we move on? No? Cool. The other thing I was just going to quickly touch on is perhaps the cheaper way of doing this through RC. Personally, I would run these certainly on the smaller builds. I wouldn't run these on a full scale R2 for all the reasons that we talked about. And as Steve said, you can switch between different systems if you want to. But what you can do is you can get very cheap speed controllers, and you can get very cheap UBEX. So I've got a little, it's about 12 quid, I think it was, this particular one that I've got here. So this is a dual speed controller, so it has 2 outputs which you can connect to 2 motors. It has a battery input, and then it has something that you just plug into your RC receiver. And it's all in one, and effectively you can run pretty much a full RC, the smaller RC droids through that. You can run the big ones through it as well, but it's just not something that you'd probably recommend. And again, just looking at the wiring, what you've got is you've got power supply, which is your high voltage, 12 volts. Your 12 volts should also go to your speed controllers. And then what you've got is a 5 volt side effectively that then starts to power your receiver, and then you can send your signals. And it's all using those PWM signals really. So the best thing to do with these is just to kind of experiment and have a little bit of play around with these. Cool. And stop that. There we go. And that was pretty much it on the basic RC setup. I think one of the challenges that I find with the RC setup is doing some of the much more advanced stuff, like triggering sounds, triggering animations. Where you want to have literally like 30 or 40 different functions and different sounds from R2 and whatnot. With an RC controller, you're limited very much just by what you've got, which is you've got a couple of sticks that control things. You've got some knobs that allow you to control a couple of other servos, and then there's a couple of switches. But there's nowhere near as many different options and different settings that you can get through, say, the PlayStation controller or the Xbox controller on the Xbox 360. How do you run yours on RC, Steve, or do you run yours on Padawan?
I'm Padawan on my R2 and RC on my 39.1.
Okay. I know there's various ways of adding extra functionality, but in many cases it seems to be either soldering pieces onto the end of your RC transmitter or finding a separate signal path for things like sounds going through Bluetooth. So it's not quite as a neat solution when you start to get multiple animations and lots of other things that are running on your droid. Cool, that's about it really, folks. Any questions or any comments? Anything that we've not covered? Does all that make sense? Is it helpful?
Yeah, good, thank you. Yeah.
Yeah.
Cool, brill. So what would be useful, I guess, next time? Where I was going with this then was once we've got the basic systems, is then to start to get into a little bit more of the logic. So where we then start to stretch into some more of the complex systems like the Arduino based ones. But the other thing I think to cover is probably sound, because I think there's another part that, again, people like to want to know more around is we actually start to trigger sounds. Is there anything else that anyone wants covering in these future sessions?
Why don't you just do a basic light setup as well, Mike, on your transmitter, so people could just use it if they just want lights only.
Yeah.
So you just buy an on-off switch on the unit, so you can just trigger it from your receiver on your actual transmitter from a switch, so they can actually operate LED lights, whichever.
Yeah, we can cover that. My default position tends to be I stick an Arduino in there, start reading signals, and get the Arduino to do some of the clever stuff. I don't.
I just mean for basic stuff for people that are out there just learning. So that
yeah.
they can just do it off that basic receiver.
Yeah, I think. Can you trigger? What's the easiest way of triggering lights off a basic receiver?
I've actually got. Yeah, no. Oh, you can actually buy off the internet like a cheap, it's like on-off switch unit. It just goes into your servo port on your receiver, and that actually then goes to a channel to your system, whichever you pick on your transmitter, and then you flick a switch. As long as you've got it into your parameters onto your system, and it will automatically switch up the system. I did have it set up the other day because I was showing Mike how to do it on a certain droid of his. For my Spectrum setup, and it's just virtually a little tiny unit. I don't know if I've got it.
I think Steve's just posted a link. Have you, Steve? In Marcel style of nodding dramatically.
It's just a little tiny unit that you can actually buy, which obviously one end goes to you've got a signal in, signal out, live and ground, and then obviously your output, say, for your lights, and then obviously it's a unit, then little unit that just actually sends a signal from your receiver to your actual lights to switch them on and off.
Okay. It's just
you just want
RC controlled switch.
PWM relay.
Yeah, it's just an RC basic transmitter from so you can actually add to your lights if you would prefer to do that. So
yeah,
especially on your mini droids.
We'll cover that. We'll cover that and a little bit of sound, I think, in subsequent ones, and then we'll probably shift into a little bit more of the more complex RC setups or Arduino setups where you've got all bells and whistles running through them, unlike like the chopper builds or the R2 builds.
Do you think, Michael, it might be worth having a 5-minute look when you do one of these future sessions at Describe?
Describe, yeah. That'd be quite cool, actually, wouldn't it? On the configuration software.
Might be interesting to just to sort of show people what you can do using the Describe software, and again, it fits in nicely if you're using just plain old RC. Yeah,
no, it's a good shout, that, Steve. So we'll do that. We'll run some of the Describe ones. We'll have a look at those little relay switches that you can get for RC. I'll go and grab a couple of those and we'll play with those, and then we'll delve into those at a later date. Fab. Okay, folks. Well, lovely to see you all again, and keep printing and sanding and printing and sanding.
Well, I've just been told, because I share my 3D printer with my son, he needs it for the next 2 weeks to do a load of D&D models.
Oh, really?
Yeah. So at least I've got the pie pieces printed now. So it is sanding and painting time, or sanding, filling, painting.
You need a resin printer if you're going into D&D models.
Yes, he's planning on getting one. Yeah,
I've got to be honest. The print that's coming off here, Mike, is pretty good for a certain person that I'm printing it for.
Yeah, so we've got an Ender 3. We bought it because it was our first printer. We didn't want to spend a lot on it, and we found out it's really the best budget printer you can get, and it has served us really well. But he does D&D models on it, but he does know he wants a resin printer next, so I'll inherit this one fully.
Brilliant.
He says if he moves out, he'll leave it with me, so he buys a resin one, or he'll take it, which means I have to buy a bigger one.
Everybody needs Everybody needs a resin printer, and you all need more than one printer. You can't possibly live without having more than one printer. I can't hear you, Andrew.
Hey, Mike, can you hear me?
Oh, I can hear you really quiet.
Oh, you can hear me. Okay, something was going on. Hey, I have a question for you.
Yeah.
On the next meeting, can we talk about I noticed in your diagram you were showing the fuse box for all the fuses. I'm having trouble finding how much amps I need and what kind of fuses I need. If you could go through that, that'll help too.
Yeah, we can cover it. Well, I think it's a nice step up from what we've been talking about. It gets a little bit more technical, but we can look at the motors, look at what the motors are rated at, and then how you'd calculate what your amps should be and how you protect that circuit. So yeah, definitely we can do that, Andrew.
Yeah, good. Thanks.
Although, just for this, I don't think Dimension Engineering, I think they recommend not using a fuse on the Sabertooth, so.
Yeah, on the Sabertooth, they don't recommend fusing it, which is interesting. I've not looked properly into why. It's something to do with the regeneration piece, isn't it, Steve?
I'm not 100% sure why myself. I have asked the question in the past about whether or not for UK Tier 1 and Tier 2 clearance, because fuses were mentioned at one of the gatherings. So I specifically asked the question of the committee as to if you had to protect it with a fuse, and they said no. So yeah, you don't have to, because Dimension actually say that you shouldn't. Now, personally, on my own personal droid, I do have a fuse, but it's of such a large capacity that it would still, the Sabertooth would still trip out first anyway, if you see what I mean. But it means that if there was a catastrophic short somewhere, the fuse would actually pop.
Yeah,
but,
I mean,
as far as the Sabertooth is concerned, it can't see it because it's bigger than 64 amps anyway.
I tend to use fuses to protect the wiring than I do components, because most components will pop anyway, but at least it stops you bursting into flames or waving your arms around to put fires out.
And it's a peace of mind.
Don't know what you're trying to say.
You can see dear old Rick in the background.
Where's Rick? Yeah.
Yeah. Cool. Okay, guys. Well, have a lovely evening, morning, afternoon, or wherever we are, and I'll probably see most of you next week. I think Bricks and Droids on next Saturday, if everybody's up for that. Now we're in permanent lockdown in the UK from Thursday.
Yes, we are, from Thursday. Yep.
Not allowed out of our house, except to go to schools and colleges, which is the where most people get infected anyway. So.
Well, I'll probably still be going to work, but where we are, we've set the offices out, so we're about 4 meters apart from everybody else, so we should be okay.
Oh no, it's a bizarre time. Anyway, and happy election day for all of you Americans as you hurtle towards another monumental decision.
So, Trump for Biden, come on, what do you want?
2020 does not need a grand finale.
Yeah, you can't.
They say that we don't need any president, as far as I'm concerned.
Not at the rate you're going, no. Not after Trump.
I elect Michael Badley.
You say Michael Badley or Bradley?
You've got probably the two of the best people out of America to fight against. It's amazing, isn't it? Really, that's the best of the best of the best, and it's Trump and Biden.
Yeah.
People are asking me who I'm voting for, and I say neither.
Yeah. Well.
Yeah.
It's no different. So I don't think.
Yeah, I'll be honest. I'm the same over here. When it comes to voting, I go by the name of the person because I don't really know politics that well.
You guys know who Doomcock is on YouTube?
No, I don't know.
No.
Nobody? Wow. Okay, never mind. Just a YouTuber I'm writing in on my ballot.
Yeah. So anyway, so good luck with that, Americans. I'm sure it'll turn out positive in whatever way it can do.
Thanks, Michael.
Yeah, best of luck to you all.
Thank you.
God help us.
It'll be the most positive
kidding.
result that anyone's ever
We'll be
seen.
definitely thinking of you. Right, see you later, guys.
Thank you.
Okay,
Yeah.
see you. Bye-bye.
Mike.
Bye.
Bye.